Bayram Veli Doyar will present. Now I will make you host.
Okay.
Just a second, please. You are host and you can share your presentation.
Okay, thank you.
Welcome.
I'm sharing now. Sorry, me. Okay, you can see the slides here. I think it's okay. Welcome, dear guests. This is Bayram Veli from Süleyman Demirel University, Turkey, Department of Economics. Today I'm going to present our study, which is co-authored by Özgür Kambi from Giresun University, Turkey. I have 14 slides of presentation. You can see the plan. We implement two analyses. One is the one-way analysis, focusing on Turkey's ICT exports. ICT is information and communication technologies, by the way. And two-way analysis, and it focus on the ICT trade between Turkey and its top trade partners. The export of information and communication technologies is one of the science and technology indicators, which captures the information about the technology level of countries. According to OECD's definition, ICT goods are the products that provide information processing and communication by electronic means. The technology in a product can be obtained through patents, licenses, know-how, or importing. In importing, technology in the imported product becomes available to the importer who owns that product. Whether the technology in this product can be learned depends on the absorptive capacity of that country. Absorptive capacity refers to the country's learning ability. The countries that absorb the technology in a product may be the producer or the exporter of that product or its improved versions. The absorbed technology may also be used in different products. Then we can say that the ICT imports can be thought as a critical determinant of the ICT exports. These implications are supported by Posner's technological gap and Vernon's product life cycle theories. When it comes to ICT, we generally think computer technologies from the demand side. In recent years, smartphone technologies have progressed significantly. However, these technologies cannot be effectively used without an internet connection. In this context, the number of internet users and mobile cellular subscribers are noteworthy indicators for the ICT demand. On the supply side, these indicators can represent production inputs because these variables provide the creation and exchange of information that will enable ICT production. In line with these inferences, our study aims to investigate the potential of these indicators to explain the ICT trade. Due to its superiority in explaining trade between countries and its frequent use, we prefer the gravity model in this work. The seminal work on the gravity model is done by Timberger, taking inspiration from Newton's law of gravity. The author explains the trade between countries. For analysis, we constructed two sets of cross-sectional data and estimate 4 different gravity equations. Now let's have a look at the literature. I will quickly pass the general studies to have time for those related to our study. It's seen that most of the studies focus on the total trade. These studies show positive relationship between trade and GDP and negative relationship between trade and distance. A part of the literature also concentrates on the impact of ICT products and or their use on total trade. These studies treat ICT as an explanatory variable. These studies generally reveal the positive impact of ICT on trade. The minority of the studies use high technology or ICT product exports as a dependent variable. For example, Green examines advanced technology goods exports of the USA to its top trade partners. Among them, some includes ICT related variables as explanatory variables. For the countries, Yushkova emphasized the role of internet use on the trade of technology goods. Within the gravity model, the results indicate that internet has positive relation with exports of technological goods. The trade of technology products for emerging and developing Asian countries, examined by Nasir and Khalil Rajan, the results indicate that the export potential of these countries is lower than the of developed countries, and internet use is an important and positive predictor of technology trade. According to the literature, it is expected number of internet users and cellular subscriptions to have an increasing impact on ICT trade. In general, we can show our model in a closed form as seen. Variables on distance, contiguity, landlockness, and island are used as proxies for shipping costs. The shipping costs are higher for distant, non-contiguous, landlocked, and island countries. Therefore, such factors are likely to decrease the trade between the countries. The land area may have two opposite effects on trade. Countries share an official language are likely to have trade mutually more because of the ease of communication. For income, we employ GDP per capita since it includes population. Its coefficient is expected to be positive. The number of internet users and cellular subscriptions are utilized to capture the ICT demand of the importer and the ICT production inputs of the exporter. Countries with higher numbers of ICT indicators, namely internet use or cellular subscriptions, is expected to have higher ICT imports and exports. This table presents the variables. These are abbreviations. X stands for ICT exports. This is distance between countries, between their capital cities. Cont is contiguity dummy. Indicates if countries are contiguous. Area stands for the total land area of the countries. Length dummy in which locked is a dummy indicating if country is landlocked, same as island indicates if a country is an island or not. Y is GDP per capita. Net and cell are number of individuals using internet and mobile cellular subscriptions, respectively. Here, the models, the equations for the one-way analysis, which focus on Turkey's ICT exports. These two equations are estimated because of the one-way nature of the dataset. Variables of the exporter, namely Turkey, cannot be employed as independent variables. The cross-sectional dataset constructed using Turkey's ICT export destinations. For most observations, the year is 2019. However, due to the lack of data, the year varies between 2019 and 16 for some observations. And here we have 153 observations. These are regression results. I estimate these equations with simple OLS. These are the diagnostics for the OLS regressions. Among geographical indicators, only the distance is found to be significant and its coefficient is negative as expected. Importers' income here has enhancing impact on Turkey's ICT exports. It's also an expected result. Higher numbers of internet users in the importer country lead an increase in Turkey's ICT export. Accordingly, a 1% increase in the internet users in the importer country brings an 0.86% increase in ICT exports of Turkey. The elasticity for mobile cellular subscriptions is way higher. Each 1% increase in mobile cellular subscriptions ends up with an 0.95% rise in the ICT exports of Turkey. These regressions pass multicollinearity tests. However, their residuals are found to be non-normally distributed. For two-way, this is our two-way analysis. We estimate these two equations, namely 3 and 4. We can use more explanatory variables because of the two-way nature of the data. As in one-way analysis, one of the equations include internet users and the other one includes the cellular subscriptions. Since there is no island country, we don't employ here. The cross-sectional data is constructed using Turkey and its top 10 ICT trade partners. The year is fixed span 2019 for each observation. And here we have 110 observations. These are our results. Variables on the area of importer and exporter are removed from equation 3 because of the multicollinearity. Also, the residuals of equation 4 were heteroscedastic. To tackle this, the model is re-estimated with robust standard errors. The distance has no significant impact on the trade among countries for equation 3. However, while a negative and significant impact is found in equation 4. The coefficients of the contiguity domains are positive and significant as seen as this. Of the variables on area, only the exporter's area is significant predictor of the ICT trade among countries. It's seen this and its sign is negative. Being a landlocked importer or exporter or speaking the same language with the trade partner doesn't make any significant change in the ICT trade for equation 3. Among these variables, only the coefficient of being a landlocked exporter is significant for equation 4, as seen here. Accordingly, landlocked exporters trade ICT products above 2.64% more than the countries that are not landlocked. This positive and rather high coefficient is not compatible with the literature. GDP per capita of the importer is significant predictor of the ICT trade. I forgot to say that I subscript shows the importer and E subscript E shows the exporter. GDP has expected sign here positive. However, the coefficient of exporters GDP per capita is found only in equation 4 at 1% level. For our variables of interest, both the coefficients of the number of internet users in the exporter and importer countries are significant at the 5% level. A 1% increase in the number of internet users in the importer country brings an 0.33% rise in the ICT trade among the country. Let's see like this. Uh, in case of the number of internet users in the exporter country here, uh, the increase is about 0.36%. Both the coefficients of mobile cellular subscriptions in the exporter and the importer countries are also significant. Each 1% upswing in the mobile cellular subscriptions in the importer country promotes the ICT trade among the countries by 0.64%. In case of cellular subscriptions in the exporter country, the increase is about 2.36%. And these estimates pass multicollinearity, heteroscedasticity, and omitted variable test. Uh, equation trees, equation tree pass normality test. However, equation 4 fails. Each coefficient has an expected influence on the ICT trade. Expect one for the landlocked dummy. The landlocked countries may be specialized in the production of these products due to their geographic positions and demand more ICT products from the other countries regarding product range. The number of internet users and mobile cellular subscribers have a trade enhancing effect on the ICT. However, the impact of mobile subscriptions in the exporter on ICT is much higher. These results may indicate that the mobile cellular subscriptions in the exporting country considerably accelerate the production and sharing of information required for ICT production, increasing the production of the ICT products and releasing them to the foreign markets. Our study, unfortunately, has no time dimension. Also, it assumes that the determinants of ICT demand and ICT production are the same, namely, these are internet users, number of internet users, and cellular subscriptions. Especially for ICT production, R&D expenditures or number of researchers may be better indicators. And these are our references. And thank you for listening.
Thank you so much. Is there any question to Mr. Doyar?